All right, so this video will go with both Tuesday and Wednesday's work because they're basically the same exact packets, except the problems have been regenerated so that they're slightly different, but they're the same concepts again. So if you do this Tuesday, you technically would not need to watch the video again on Wednesday. You could just do the next packet. There are a few ways to factor, and this packet reviews those ways that we factor. The first thing that we could do is something like this. If we have 18a squared minus 6a, we could pull out a common factor. In this situation, 18 and 6 share the factor 6, and a squared and a share the factor a. So then when we take a 6a out of this, I'm left with 3a minus 1. And that's all. That's all you're doing when you're pulling out a common factor is you're just pulling it out and then having it simplified. And this is done. The first 4 problems are very straightforward and simple. You're just pulling out a common factor. The next few problems are factoring quadratics. Oh, I need a new pen. So in this situation, let's go with, I've got an example right here. N squared minus 11n plus 24. In this situation, you should have done these before. You're going to need to factor this down. The basic idea being that the two factors of this need to add up to be negative 11. Now, when the last part of it is positive, it means one of two things. Either both of these signs are negatives or both of these signs are positives. We can't be sure, but what we do know is that a negative times a negative is a positive, and a positive times a positive is a positive. So either both of these signs that go here they're either both negative or both positive. Because the only way to get this to be positive is for both of them to be negative or positive. One can't be minus and the other one plus. How we figure that out is we look at this one. If this is negative, then they must both be negative. So then we have 24. Two factors of that would add up to 11. I already know the answer, but for sake of explanation, let's go with, we could say 1 and 24. We could say 2 and 12. We could say 6 and 4. We could say 3 and 8. Obviously 3 and 8 added to 11, so it'd be n minus 3, n minus 8, or they could be flopped. It could be n minus 8 times n minus 3. But the idea being that you're going to look for the two factors that add up to 11. This can get trickier once the front coefficient is no longer a 1. And I'll give you an example of that here in a second. Every time we do one of these problems, though, we also want to factor out any common factors. I'll give you an example of that. Let's see, 10m squared minus 26m plus 12. This one, I could take a 2 out of this, a 2 out of this, and a 2 out of that. So I'm going to go ahead and do that. Okay, now this is harder because I've got a 5 out here. This is harder to factor in your head, but it's really good to be able to do. It's really important to be able to do this. So when I look at this, I need factors of, what I know is that 5 can only break down into 5 and 1. It can't break down into anything else. So I know it's going to be 5m and a 1m. The other thing I know is that this is positive. And what does it mean when this last part is positive? They're either both positive or both negative. One or the other. Well, I look here. This is negative, so they're both going to be negative. Now 6 can be broken up many ways, but what we know is that our middle term's got to be 13. And 6, in order to get there, we might have to do some fun things. We know the 5 times this outside is going to give me one piece of the middle term, and this unknown, this 1 times this unknown will give me the other piece. So let's go through how we would work this. 6 can break down to 1 and 6, can break down to 2 and 3, all right? So let's do it with 1 and 6 first. Let's imagine I put the 1 here and the 6 here. I would end up with a 30m, a minus 30m, and a minus 1m. That would equal negative 31m. That can't be right. So then we would check if we were to flip them, what would happen. So let's imagine I put the 6 here and the 1 here. That would give me a negative 5m and a negative 6m. That would give me negative 11m. That does not match 13. That can't be right. So I know that this is not possible. So let's try the 2 and the 3. The 2 and the 3. So let's put the 2 here, or let's put the 3 here and the 2 here. That would give me negative 10m, negative 3m, negative 13m. That's it. This is our answer. If that hadn't worked, I would have flipped them. I would have put the 2 here and the 3 there. The idea being that you've got to flip them around enough to get them to work correctly. A lot of this is just practice. The more you do it, the better you get at it. So if you're having issues, I am able to generate tons and tons of these worksheets, no problem, to give you lots of practice to make you very proficient. All right, next thing. Make sure you always take out the common factor on those and then break it down as far as you can. The next thing we want to go over is the difference of two squares. The difference of two squares looks like this. And what that means is, first of all, the difference is the answer to a subtraction problem. And here's our subtraction sign. And two squares means the first number is a perfect square, and the last number is a perfect square. So in this situation, we have x squared minus 2 squared. They're both perfect squares. In this situation, there's a formula for it, which you must know, and that if you're going to pass my class, you're going to have to know it. It's going to be x minus 2, x plus 2. And let's work this out just to make sure that you can see why. If I went ahead and put this through, I would end up with x squared plus 2x minus 2x minus 4. These cancel each other out, plus 2x and minus 2x. I'm left with x squared minus 4. It works this way every time. Sometimes the problems are more difficult though. For example, let's say I had 25m squared minus 4. This is a perfect, first of all, it's subtraction, so it's the difference of two squares. 25m squared is a square and 4 is a square. 4 is 2 squared, and 25m squared is 5m squared. If I took 5m squared, I get 25m squared. So what I do is I take 5m minus 2, 5m plus 2. Difference of two squares. You must know it. You must know it. There's no way around it. You have to, must know it. You need to know it. You have to know it. All right. Another example, and don't let this throw you off, is if they happen to put the constant in front and the variable in the back. Now in this situation, it's weird because you get this end of the fourth, so you're thinking maybe not so much, but it's still the difference of two squares. This is 6 squared. This is 7n squared. That would give me 49 n to the fourth. So here we do the same thing. 6 minus 7n. 6 plus 7n. I'm always following the same formula. The first one minus the second one. The first one plus the second one. It may help you to watch this video, do the problems, and then watch it again the next day on Wednesday if you're having issues, because you might understand it better the more you practice. Okay. And lastly, we have factor by grouping. This is a more difficult concept that isn't taught. It's actually not that difficult, but it's not taught in a lot of places. So they don't teach it specifically, and I think it's a must. You run into it, you need to know it. First of all, you know you have to factor by grouping when you have 4 terms. 1, 2, 3, 4. We got 4 terms. And this is how factor by grouping works. We pretend we're going to look at the first set of 2 and the second set of 2 alone. All right? So when I look at this, what could I take out of both of these? I could take a b squared out. That would leave me with b minus 1. Then I bring down my addition sign, and then I'm going to look at this. I can take a 2 out, and that leaves me with b minus 1. All right, so what do I see here? I see that I've got a b minus 1 here, and a b minus 1 here. Now, what would you do if instead of having a b minus 1 here, what would you do if you had a b squared z plus 2z? You would see that you have a common factor. The z is common. And since the z is common, we can take it out. So I would end up doing this, z times b squared plus 2. But this wasn't a z. This was really a b minus 1. So I'm going to go ahead and write in b minus 1, b squared plus 2. And I factored it. It's factored. Yay. I'm going to do another one of these. Okay, so next one. Let's go with 9n cubed minus 12n squared plus 3n minus 4. So I've got 4 terms. The only thing I can really do with 4 terms is take some common factor out of the whole thing or factor by grouping. So I'm going to group these 2 together, and I'm going to group these 2 together. Now, I'm going to look at this. What can I take out of both of these? I can take a 3 out, and I can take an n squared out. That leaves me with a 3n minus 4. If I take 3n squared out of 9n cubed, I get 3n. If I take 3n squared out of 12n squared, I get 4, negative 4. Then I'm going to have plus 3n minus 4. I don't have to do anything to that. That's kind of convenient. So now, let's imagine, instead of this being 3n minus 4, let's imagine that it's x. That would mean we have 3n squared x plus x. Well, that's easy. We just take the x out. X times 3n squared. Now what happens when I divide x by x? If you say I get a 0, you should hit yourself in the head again, because you really are left with a 1. X divided by x is 1, not 0. Okay? So this is what you need to remember there. Some kids like to just say, oh, I'm dividing that by x, it's going to go away. Okay, so here's what we have, but we really didn't have an x here. We had 3n minus 4 times 3n squared plus 1. Now I'm hoping that you understand what we're doing here with factor by grouping. We may need to cover this a little bit more. That will be shown by how well you're able to do these problems. So you may need to watch this a second time, but see if you can get it. If you can't get it, I'll do another worksheet on this, and I'll do some more video instruction on this. That will be it for Tuesday and Wednesday's stuff.